Yes. Hello, everybody. So this session is very special session for everyone. I'm just going to discuss some of the question, from data science and artificial intelligence. And I'm Dheeraj. Okay. And I teach mathematics for all the branches. Okay. And aptitude as well. So here I'm going to talk about one of the very important topic. Hi, Sahil. Welcome to the class. Okay. So today I'm just going to take question from linear algebra subject. Okay, in data science, linear algebra is nothing but you know. So this session will be on linear algebra. You can say linear algebra, and some of the concept also I will discuss. Right. So I've taught this mathematics for February batch. Okay, so you see here this how many question has been asked from linear algebra in gate DA. Okay, in gate DA. Okay. So for 1 mark there was 3 questions, and for 2 mark there are 4 questions. So total you can expect is around 11 marks from the linear algebra, right? But not in CS branch. In CS branch around you can expect 4 marks, but in data science and AI the huge weightage is there. So what is my plan for today is I'll take question from the sample paper and we will solve that questions, and we'll also understand some concepts, right? Okay, you see this is a very first question which is given in your paper. So both of you have to try this question, then I will also answer the question. So let us read the question here, then we will also cover some background needed to solve this question. Yes. For matrix, this matrix is given. You can say all the element of this matrix is real. So this matrix is real only. This matrix is 2 by 2 matrix. One of the eigenvalue they have given is 5. Okay, so other eigenvalue is what? Right? Other eigenvalue is what? So can you answer this question, and how much time you're going to consume? That is also very important. So there is a property, right? There are some properties related to eigenvalues, okay, and eigenvector, right? If you recall, so suppose we have got 2 by 2 matrix, okay, 2 by 2 matrix, you can say any matrix is given 2 by 2 matrix, okay. So right, Chiranjeevi, okay. Aditya is saying B is the correct answer, right? So we can check also quickly. Yes, B can be the correct answer. Sahil, are you agree with this answer? Yes. Dekho, so suppose we have got this matrix A, okay, 2 by 2 matrix. So we can form the characteristic equation and we can get the eigenvalue, right? But suppose we have got matrix of as the order of the matrix increases, like 3 by 3 matrix, any other matrix. Suppose we have got 4 by 4 matrix, you can say 4 by 4 matrix. And as the order increases, right, so it will be very difficult to compute eigenvalues and eigenvector directly, right? I mean, by forming, you can say, the characteristic equation and all. So what they have done was they introduced some of the very useful properties of eigenvalues and eigenvectors for higher order matrix, right? So what they said was there are two important property that you have to remember. Okay, two important property. The number one property is nothing but sum of all the eigenvalues, right? Sum of, so there are two property. One is called as sum property. One is called as product property, right? See, okay, sum of all eigenvalue is going to be equal to, right, trace of the matrix, trace of a matrix. This is a sum property, okay, related to eigenvalue. Second property is the product of all eigenvalue, right? Product of all eigenvalue, right? Product of all eigenvalue is going to be equal to determinant of the matrix, det of matrix, right? So these are the two properties which are very useful when the order of the matrix increases and you are not able to form the characteristic equation, or you are able to form the characteristic equation, but solving that equation becomes very tedious, right? So as long as this matrix is concerned in your sample paper, that was question number 17, right? So this matrix is 2 by 2 matrix, okay, and one of the eigenvalues is also given. So you don't have to form characteristic equation and all. you have been given one of the eigenvalue, so second eigenvalue you can find out, right? So suppose let us use this sum property directly. Sum property is what? Sum property, you can say directly, you can use sum property. What sum property says? Sum of the eigenvalues. So one of the eigenvalue is lambda, second eigenvalue is lambda 2, you can say, and that is nothing but trace of the matrix. Trace is nothing but this addition of the principal diagonal element. Okay, so that is nothing but 9 plus 6. Okay, so one of the eigenvalue is given, another eigenvalue you have to find out. So lambda 2 is going to be 15 minus 5. So lambda 2 will be 10. So I hope this makes sense. So option 10, option B will be correct answer. Sahil, you understood, and Aditya, both of you. So those who have attended my class, in February batch, right? So they might have seen this kind of a thing. But those who did not understand, I mean, did not attend my classes, so they might have attended some other classes, right? So I believe this is fine. Yes, Aditya and okay. So I hope you understood. So whenever higher order matrix will be given, so you have to always recall these two properties, sum and the product property, right? Sum and the product property. Let us move to next question. This question is very good question. You can see again question number 18, right, from the linear algebra only. The background needed will be, I will tell you, right. So here they have given two non-zero vectors x and y. Okay, are perpendicular. They are saying perpendicular. What is the meaning of perpendicular? You know, the another name of perpendicular is nothing but orthogonal. 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 Okay, orthogonal. So if you want to if you want to multiply two vectors, okay, so what are the ways that you can multiply two vectors, right? So you can multiply, suppose you have got x vector and you have got y vector, you can say there are two vectors, and if you want to multiply them, so what you will do here is, okay, suppose these are the vectors, you can say x1, x2 and x3. Okay, the dimension of this vector is 3 here because there are three components, and here by 1, by 2, by 3, right? Suppose you want to take the dot product of them, right? Dot product of them. Okay, so how can you multiply two vectors? That is very important to keep in mind. Can you tell me, Sahil, how can we multiply these two vectors? Because after all, these two vectors are having, if you see the order of this matrix or vector, that is something like 3 is to 1, 3 cross 1, and this is 3 cross 1, right? So you can't multiply directly these two vectors, right? These two matrices cannot be multiplied directly. Okay, what is the need? What is the reason behind that? Huh? Because their orders are same, but the thing is, the number of column, okay, in the first matrix, okay, and the number of rows in the second matrix is not matching. Okay, like they are not conformable to each other, you can say. That word is very important, conformable. Conformable, right? Then how to take the product of two matrix? Then what you have to do here is you have to take the transpose of one of the matrix, right? So you can see we are taking the dot product here. Dot product is going to give you the you can say kind of scalar value only. Dot product is known as scalar product also. So x dot by, so you have to do like this, x transpose by, or you can say that x by transpose. Okay, both are going to be same, right? Okay, so in terms of matrices, please remember this. You can't directly multiply two vectors here. So what you have to do always is you have to take the transpose of one of the matrix, right? So if you take the transpose, so here the order will reverse. 1 is to 3 it will become, right? Or you can also take the transpose of by and then multiply. Or what you can do here is, this is one format that you have to remember, or you can multiply directly like component wise multiplication, right? Dot product is done component wise multiplication, you can say component wise multiplication, right? So what they are asking is, they are saying that two non-zero vectors x and y are perpendicular to each other if x dot by is equal to 0. Yeah, if x dot by two vectors is equal to 0, means they are perpendicular to each other. They are perpendicular to each other. Okay, or you can say they are forming 90-degree angle. Okay, they are forming, perpendicular means right angle. Okay, and if there is a right angle, means you can also go for Pythagoras, right? Go for Pythagoras. Pythagoras also we can apply. Understand? Pythagoras theorem we can apply, right? So in other words, what you can do here is in terms of matrices, you can say that this become equal to 0, or you can say also that this. I hope this makes sense, guys. There is no doubt. Okay. See, if two vectors are perpendicular to each other, so their dot product must be equal to 0. Okay. If their dot product is equal to 0, it means they are forming 90-degree angle. Suppose this is a vector x and this is a vector y. So you see, guys, x and y. Okay, x and y, x and y. This is very, very important. X and y. So x dot y is going to be equal to cos of 90. So that becomes 0, right? So which answer is going to be correct? This is wrong, right? This is also wrong. This is also wrong. So option A is going to be correct. Okay. So orthogonal is nothing but, see, two vectors are orthogonal and two matrices are orthogonal. Both are different thing. Okay. Two vectors are orthogonal. This is very easy fact, right? So remember that. Okay. This is how we can multiply two matrices. Otherwise, you can't multiply two vectors. Okay. That is the reason this idea comes into picture. I believe now it is clear. Yeah. And we can also prove that. But we can also prove that x transpose y equal to 0. We can prove this, right? So this is very, very important to keep in mind. Okay. I believe this is fine. Can we move ahead? Yes. Is there any doubt? Please let me know so that if no doubt is there, it's fine. And you guys can also speak if you have any sort of doubt. Okay, fine. Let's move ahead and we will cover more concept once this all the question will be over, right? You see. Now, question number 25. Again, they have asked question from eigenvalues. So it is a clear indication that they will be asking question from matrices and the eigenvalues certainly, right? Okay. So from linear algebra, eigenvalue is one of the favorite topics. So they have given here two eigenvalues of 3 by 3 matrices, a matrix X R 1 plus iota and 3. So it is a 3 by 3 matrix, means there will be 3 eigenvalues, right? 3 eigenvalue must be there. So one of the eigenvalue you can say lambda 1 is this and lambda 2 is this. Can you tell me the third eigenvalue? Third eigenvalue. See, always remember that, yeah, this is by default, yeah, it is correct, okay? Suppose your one of the eigenvalue is complex. So complex always stays in pair, remember, stays in pair. Or you can say that eigenvalue is third. They also stays in pair, guys. Okay. Or imaginary, purely imaginary, you can say. They also, stays in pair, right? If one of the eigenvalue is given and that is complex eigenvalues, they will be always staying in pair, right? So you have to go for complex conjugate, right? So here they are asking determinant of the matrix. Again, I'm telling you guys, you know the property as the order of the matrix increases, right? So there is a property called sum and the product, right? Sum and the product. So they are asking determinant of the matrix. Determinant of the matrix, you can say det of a matrix A, you can say, or X matrix, you can say X will be the product of all eigenvalues. Product of all eigenvalue, right? How simple this concept is, right? So now you don't have to remember it. Surd means what? What is the meaning of surd? Suppose your eigenvalue is root 1 plus root 2. So another eigenvalue will be 1 by root 2. Okay. Imaginary means suppose one of the eigenvalue is I, so another eigenvalue will be minus I. If complex matlab, suppose one eigenvalue is A plus iota B, so second eigenvalue will be this. Okay, fine. So these are the overview that you should know. Now, what you can do here is, let us do the product. 1 plus iota, 1 minus iota times 2. So you can recall here a plus b, a minus b. This is nothing but 1 square minus iota ka whole square into 2. Iota whole square is nothing but minus 1, so it becomes 2 into 2, which is nothing but 4. I believe now it is clear, yeah? Any dikkat, any problem, anywhere, any sort of problem, any sort of doubt? So many students, they do not understand that. Suppose one of the eigenvalue is 1 plus root 2, right? So another eigenvalue can directly be determined by the fact that they always stays in pair, right? Let's move ahead. Again, they have given one question from eigenvectors, right? And this is one of the very good question. Okay, they have given. So can we try this question, everybody? Yes. Can we try this question and try to tell me what answer is going to be correct? Okay. So this is a question number 37 in your sample paper. If you look at sample paper from the official website, so they have given here the matrix H. Okay, that is nothing but 3 minus 1 minus 1 3 and one of the eigenvalues. So first of all, whenever any matrix is given, you have to look properly. Okay, this matrix is nothing but a symmetric matrix, I believe, kind of symmetric matrix. There are some special kind of matrix, orthogonal matrix, symmetric matrix, skew symmetric matrix, okay, uh, projection matrix, rotation matrix, okay. There are some special type of matrix. Being data science and AI aspirant, you should know in deep about these sort of a matrix. And always these matrix should be always in your mind. Okay. So my main job is not only to find out eigenvector here. You have to identify this matrix. If you are able to identify the matrix, so your life becomes very simple. You see, for the H matrix, one of the eigenvector is given, that is nothing but minus 1 and minus 1 transpose, right? So you can also write this as like this, component minus 1 minus 1 here. Okay. So other eigenvector is what? What is the next eigenvector? What will be the next eigenvector? Can you tell me here? Yes. Please try to find out. So see, there are many ways to solve this question. You can find out the eigenvalue, right? And then you can use the property called Ax equal to lambda x property, right? Okay, that you know. The property is nothing but Ax equal to lambda x. Okay, this is one of the very good property. Okay, it should satisfy. So here the matrix A is given. Matrix A is nothing but, I'm solving this question conventionally, the way you guys are, I think, might have done or will be solving this, right? So you can say this is method 1 I'm telling you. And then I will tell you my technique. Okay, that is the real technique. Okay, so conventionally we are solving this question. Okay, let me erase this from here, and we will go to next page and then we will try to solve. Okay, so meanwhile I'm telling, yeah, so Aditya is saying option A. Let us see which option is correct. Okay, as answer key is not given, so we have to solve this question, right? So uh, we know that hx is equal to lambda x, right? So here one of the eigenvalue is given, so let me write the matrix first. Okay, so the matrix is nothing but 3 minus 1 minus 1 3. And Aditya, can you tell me which method you have followed? I mean, what logic you have applied here, right? So that and here let me write the eigenvector. One of the eigenvector, you can say kind of x1 eigenvector, minus 1 and 1, okay, is equal to lambda 1, you can say minus 1 and minus 1. So from here you can find out the vector eigenvalue, right? So if you try to solve this, so it is nothing but minus 3 plus 1 equal to minus lambda 1. So minus lambda 1 is nothing but minus 2. So lambda 1 is 2. Since we have got the, okay, this is very important to keep in mind. Lambda 1 is 2 here. Okay. We have got the lambda 1 is 2. Okay. Now lambda 1 is 2. So lambda 1 plus lambda 2. Second eigenvalue you can find out quickly, right? From here. Lambda 1 plus lambda 2, which is nothing but trace of the matrix, which is 6. So lambda 2 is nothing but what? 4. So since we know that Ax equal to lambda x, right? Ax equal to lambda x, so you can use that property. So what you have to do here is you have to pick up from the options. Okay, you take any option, like Aditya said option A. So let us take option A, right? Okay, let us take option A and then plug here. So now option A. Okay. So we have got matrix 3 minus 1 minus 1 3, and the eigenvalue we have taken from the option A is nothing but 1 minus 1, and this is nothing but 4 times of uh, 1 minus 1. Let us see. So if you multiply these two matrices, okay, so that should come out to be 4 and minus 4. Let us see. So 3 minus 1, so this becomes, yeah, 4. Perfect. And this becomes minus 1 and minus 3, that is nothing but minus 4. Yeah, so I think this option will be correct. Yeah, so you see, this is one of the method that we have to follow. Directly we are able to verify the options. So we are getting this 4 and 4. If you take out 4, so we are getting here 1 minus 1, right? Okay. So option A can be correct here. Option A can be correct. But it is taking little time. See, 2 by 2 matrix is there, it's fine. Life is very simple. But suppose the matrix is 3 by 3 matrix, and then as the order of the matrix increases, okay, and then it might become difficult to follow this kind of method. But ax equal to lambda x is always correct. Ax equal to lambda x is always correct. What is the meaning of that? Ax is parallel to lambda x. Okay, understood everybody this concept? Sahil, you understood this concept? Yes, very good. But let me give you my technique, the very important technique that you can do here. Since a special sort of matrix is given, what they have given here is the for matrix H, okay, and H is nothing but a symmetric matrix, as I told you, right? H is nothing but symmetric matrix. Okay, symmetric matrix. So this question can be done in few seconds then, right? You don't have to do all these things. See, the concept which you have to use, okay, if the matrix is symmetric matrix, right? So eigenvector corresponding to, remember, eigenvector corresponding to different eigenvalue of a real, okay, corresponding to different, okay, eigenvalue. Okay, so eigenvalue should not be repeated, different hona chahiye, or you can say distinct. Okay, distinct eigenvector corresponding to different eigenvalues, okay, of a real symmetric matrix of real. So this concept is only useful in case of real symmetric matrix. Okay, this is my experience that I'm sharing with you, right? As long as I have been teaching for linear algebra for longer duration, so I got to know that this kind of concepts, so, and these are much faster technique to solve the question. So eigenvectors corresponding to different eigenvalue of a real matrix, okay, of a real symmetric matrix. So this is only applicable for symmetric matrix. Okay, are orthogonal. क्या? Orthogonal. I hope this makes sense, guys. If you know that there are two different eigenvalues of a matrix and the matrix is symmetric matrix, so you don't have to find eigenvalue. Then what you have to check here, the two eigenvectors must be what, guys? Okay, two eigenvectors must be orthogonal to each other. Okay, and vectors are orthogonal means what? Their dot product must be 0. I believe now this is okay, right? So you can solve this question. You don't have to follow this is a conventional approach that everybody do. Conventional approach, everybody knows, right, in India. So you see, one of the eigenvector is this. Now you take -1. Let me use this property, right? Okay, so, okay, by concept, how can we solve this? What you have to do here is you take one eigenvector here, -1 and -1, and you take this eigenvector, right? D option. So take the dot product of that. Yeah, you're not getting 0, right? So this is not correct. If you take dot product with this, again you're not getting 0. Again you're not getting 0, right? You will get here -1, -1, that is -2. But in this case, you will get here -1 and +1, that is become 0. I hope this makes sense, guys. सबको समझ आया क्या? Hmm? So please always, whenever question will be given, okay, whenever question will be given, you have to remember this. Please add, okay, in your gate computer science also this concept can be useful directly, right? Okay. So you have to remember that this property is only useful when there are eigenvectors corresponding to distinct eigenvalue for real symmetric matrix. Okay, then they are orthogonal to each other, and you don't have to find eigenvalues here. Okay, so one step process, only take the dot product and find the answer. Fine. Okay, so one of the very important concept again, we have got here question number 38. So Sahil and Aditya, now you are satisfied with this question or not? See, this question can be done in 1 second, in fact less than 1 second, right? The moment you read the question and you get the answer, क्योंकि आपको पता चलना चाहिए कि you don't have to always keep in mind अच्छा this method, okay, many people do like this and they might spend 5 minutes also in this, but this if you know this, only 5 seconds. Question number 38, guys. Question number 38, and it is quite amazing problem. And this problem directly asked from my sessions only, right? Whatever session I take, right? So let us read the question and try to understand each and every line, okay? Each and every line of this question. So what they have given here is the following statement are made regarding a matrix A, M cross N. Here the matrix is, M cross N. Okay, the first statement they have given is the column space is orthogonal to the row space. What they have given? The column space is orthogonal to the, you can say, row space. The column space is orthogonal to the left null space. Okay, the the row space is orthogonal to the null space. Okay, and the null space is orthogonal to the left null space. Okay, we'll see what is the meaning of left null space. Okay, so what are the options they have given here is, the options they have given is which of the following statements are true, right? So this is nothing but a MSQ question, guys. MSQ, and this question is for 2 mark. So options say like P and Q only, P and R, Q and R, and P and T. Yes. So both of you, can you tell me which of the options are correct? Yes, guys. Quickly tell me fast. Yes. So that we can discuss and then, okay. Yes. Any hint? So you have to remember that this is a concept of orthogonal complement, guys. Orthogonal complement, right? So what they are saying is the column space is orthogonal to the row space. Column space is nothing but what? Can you tell me what is the meaning of column space? Yes. What is the meaning of column space? Hmm? What is the meaning of row space? What is the meaning of null space? Fine. It's okay. If you don't understand, fine. We'll discuss that. So column space of a matrix, column space of a matrix, you can say A is written like column space of A like this. Okay. I think this is clear. And you can also write row space of a matrix, row space of a matrix A, you can say M cross n can be written as the column space of A transpose, right? If you take the A transpose, right, take the A transpose, that will give you the column space of, that will give you the row space of a matrix, right? This is very, very important to keep in mind. Okay. This is very, very important to keep in mind, guys. So column space and the row space. Okay. I hope this makes sense. So column space is nothing but all the vectors will be present, okay, and like all the columns are going to be present in the space, in the vector space. Row space is nothing but what, all the row vectors are going to be present in the that space, okay, and they will follow some concepts, right? I mean, they will follow all the vector space property, right? Do you know what is the vector space property? How do we say that any vector space is a, any space is a vector space? Vector space. What is the meaning of vector space? See, vector space is nothing but what? Vector space is nothing but suppose there are two vectors, you can say u and v. Okay. Suppose u and v are the two vectors. U belongs to the vector space v, and v belongs to also the vector space v, right? So u plus v should also belong to the vector space v, and if you multiply something with u should also belongs to the vector space v, okay. Beta times v should also belongs to the vector space v, right? Okay, these are the property. What we call this kind of property as, this is nothing but closed under addition, right? We call it closed under addition, right? See, if you have been given a bunch of vector in your hand, okay, suppose one vector belongs to a space v, vector space v belongs to vector space v, right? Then if you add those two vectors, so they must also stay in the same space, right? They must not go into different space, okay. Understand? So, and if you multiply by any scalar constant, so this is nothing but a multiplication by scalar constant, okay. So that should also belongs to the same space, okay. If you multiply beta, okay, and if you take the linear combination of them, you can say lu, okay, and beta times v, that should also belongs to the vector space v, okay. So this is a property of vector space, okay. So it should be closed under addition, so that we call it as closure property, right? And the second property is nothing but multiplication by a constant, okay. So if someone is going to ask you, suppose I give you two three vectors, so what are the things that you can do with the vectors, right? You can add two vectors, okay. You can multiply by any number, okay. If you're going to multiply by any number, scalar constant, to any vector, what will happen? Can you tell me, Adit, if you have any vector and if you're going to multiply that, so what will happen basically? Yes, what will happen? So suppose you have got a vector here, okay? This is a vector kind of thing, and you can say that this has 5, okay, magnitude here, right? X vector. If you're going to multiply something by this, you can say 2x you want to find. So what will happen? This vector length will be increasing like this, okay. It will become 10, okay. What is happening here is that the vector is not changing its direction, right? It is just, you know the length is getting increased, okay. And and uh, and uh, what you can do here is, in other words, you can say that what will happen, stretching will happen. Stretching, okay, stretching is happening, your vector is increasing, okay. That is very important to keep in mind, okay. So this is very, very important to keep in mind. So any vector, you can say there is some vector v, okay, and okay, let me say that suppose any vector v is there, and you can say v is nothing but some subspace of a vector space Rn, right? So what will be the orthogonal complement of V, right? Orthogonal complement of V. Okay. Orthogonal complement we denote by V perpendicular, right? This is nothing but an orthogonal complement. Okay. So orthogonal complement is going to be what? There will be some vector, you can say, there will be some vector, okay, that will also belongs to the Rn, right? Such that if you take dot product of x with V, right? If you take dot product of x with V, so that should be equal to 0. Okay. For, you can say, for every V belongs to capital V. Okay. And that is very important, and this will also be the subspace only, you can say, right? So subspace and vector space, those are very important concept. Okay, so you have to remember that, and that is nothing but the heart of linear algebra, right? So we will come back to the question, right? So here they have given that the column space is orthogonal to the row space. Remember that the column space, this first statement will not be correct. Okay, okay. Remember, this is very important to keep in mind. So what we can do here is we can say that, always remember the if I talk about row space, right? So if you take column space of A transpose, that is going to be nothing but of row space of a matrix A. Okay, always this is very important to keep in mind. And if you're going to take the orthogonal complement of this, orthogonal complement of this is what? Orthogonal complement of this, okay, that is nothing but perpendicular, right? Orthogonal complement of row space is going to be equal to the null space, guys. Okay, it is one of the very important property that you have to remember always. Okay, orthogonal, what you can say here is orthogonal complement of, or orthogonal, you can say, or orthogonal complement of row space is nothing but, okay, nothing but a null space, right? Null space. Okay, ये first property that you have to remember. And what is the meaning of this? This is nothing but a orthogonal okay, that I have told you here. Okay, this next. And if you're trying to take here, this is nothing but this. Okay, and suppose you are trying to find here, okay, the orthogonal complement of a column space. Okay, remember this. 1 minute, let me take one more page here so that this is very good question. Okay, may not be covered. Yeah, so let us see now. So what we were discussing here is, again I will start from the same. Okay. We will solve these questions. So let me recall here what I'm trying to say here is, the first is orthogonal complement of, okay, orthogonal complement of row space. You can say that A transpose, okay, complement is going to be equal to null space. Please remember this. Okay, orthogonal complement of row space is nothing but a null space. And if you're going to take the orthogonal complement of column space directly, orthogonal complement of column space. See, C of A is nothing but column space. Okay, and if you're taking column space of A transpose, so that is nothing but row space. Okay, so row space of a matrix can be written as always. Remember, row. This is nothing but row space. Row space is R of A. So, for orthogonal complement of column space is nothing but what? The left null space, guys. What is left null space? Left null space is this. This is called left null space. Left null space. See, n of A is nothing but a null space. N of A is nothing but null space, right? And n of A transpose is nothing but left null space. I hope this makes sense. You understand, guys? ये terminology is clear or not? Now you started feeling about this question or not? See, null space of A is nothing but any. And what is the meaning of left null space? Left null space is nothing but you take the transpose of a matrix A and then find the null space. That is nothing but left null space. And if you take the orthogonal, okay, orthogonal complement of null space, orthogonal complement of orthogonal complement of what? Left null space. Complement of left null space, which will be what? You can say that this is left null space, okay, and you're taking the perpendicular, okay, orthogonal complement. So which can be written as, in place of n A transpose, you can write this. So this is nothing but, okay, and overall you are again going to take one more perpendicular, right? So you are taking the complement of a complement, right? Complement of a complement. So you should remember one property. Suppose any vector space is there and you have taken the orthogonal complement of a vector space, and again if you're going to take the orthogonal complement of a vector space, so that will be nothing but a vector space itself, right? If you're taking two times, like in the case of a transpose, like A transpose A, like you might have seen any matrix is given, and if you take the transpose and transpose, so the matrix becomes A itself, right? In the same manner, if you're going to take two times of the complement, and this complement is very special complement, that is nothing but orthogonal complements, right? So by following the same language that you can follow here, this becomes what? The column space. So what you can conclude here is orthogonal complement of a left null space is nothing but a column space. Okay. So there is a symmetry you can find. Symmetry, right? What kind of symmetry? See, the orthogonal complement of row space is nothing but a null space, right? And orthogonal complement of null space is going to be a row space. Okay, that is, vice versa is going to be true here, right? In case of null space, okay, if you're going to take the orthogonal complement of a left null space, right? Or you can say orthogonal complement of column space will give you left null space. So let me write here orthogonal complement of column space is equal to left null space. Let me come back to the question now and try to solve this. Okay. So now let us see this first question. Yeah. So what they have given here is the row space is orthogonal to the null space. Yes. Can we say, yeah? Statement R is correct or not? Tell me first. Yes, Aditya and Sahil. And statement Q you read. The column space is orthogonal to the left null space. Yes? Okay. If you see, there is a symmetry. You can also say that if you take the orthogonal complement of, you can say, column space, you will get the left null space. But if you're going to take the orthogonal you can say, if you're going to take the orthogonal complement of left null space, so you will get the column space. So symmetry is there, right? So these Q and R is correct. Now null space is orthogonal to the left null space. Let me check here, right? So null space is orthogonal to the left null space. Okay, so we have got left null space, right? What is left null space, guys? Let me try this. Okay, this is very important. Left null space is nothing but this. And if you're going to take the complement of this, right? If you're going to take the complement of this, so you can write this as what? Can we write like this? Yeah. because from this property you can say that uh, yeah, from this property. Okay. So you can put here, right? So it is also not okay, right? So which options are correct here? See, and this will not be correct. Okay, this will not be correct. Okay, so only Q and R are correct. Yes, everybody is able to understand or not. So option Q and R, which option is correct here? Okay. See, by default you can ignore these. Why? Because there is P. Only one option will be correct. Okay. So you can recall, guys. I will suggest. I mean, go through one book. I will suggest here. That book is named as Gilbert Stein. Right. In future, you can go through after the exam. Not because now we have got less time, so you can get in touch with me only. But later, if you are interested, right? So yeah, fine. So some feeling was there or not? Tell me fast. Okay. So let us see this question. Question number 39. So the question says here is that consider a matrix 0 1 0. Okay. I will cover some background also, guys, after finishing all the question. I will teach you. Okay. Some basic concept. Yes. इसका बताइए. Yes, Sahil and I think Aditya. Now you guys can answer this question. So consider a matrix 0 1 0 A to D V3C, right? The matrix cannot have a rank. See, options are like 0 1 2 3. The rank of a matrix will be 0 only when all the element of the matrix is 0, right? Okay, but here some of the matrix element are not 0. See, 1 2 3, but these guys are 0, you can say, right? Okay. So some element will be non-zero. If one of the element is non-zero, right? Suppose all the suppose this row is 0, you can say, but okay, this row is also 0, but one of the element will be non-zero. Okay, so one of the row will be non-zero, you can say, right? So so here 0 cannot be the rank of the matrix. Only this option will be correct because they are asking that the matrix cannot have a rank. Okay, if the matrix is non-zero matrix, okay, so the rank will be at least 1. Okay, depending upon how you find the rank of the matrix. So rank of the matrix can be found out. Rank of the matrix, what is the meaning of rank of the matrix? Rank of the matrix, rank of the matrix is nothing but what? Number of pivots. Okay? We call it number of pivots. Okay, uh, and rank of the matrix. Okay, or you can say that number of linearly independent independent number of linearly independent column, you can say that column, right? Number of linearly independent row. Okay, there are different, okay, yes. And dimension of column space, dimension of row space of a matrix. Okay, there are many definitions. Okay, rank of a matrix has many definitions, guys. Okay, number of pivots, number of linearly independent column. Okay, number of linearly independent rows. Okay, and dimension of a column space, dimension of a row space. Okay, and how do we define? Define dimension of any matrix? Do you know that? Yes. How to find dimension of any matrix? Just by finding the basis vector, right? If you know the basis vector, in set of basis vector, how many set of basis vectors are there in the basis, right? That is going to be the dimension. Okay, chalo, okay. And basis is nothing but what? That you should know. The basis, There are two words which is very important: basis and dimension. Basis is nothing but the intersection of what? If the matrix, if the vectors are linearly independent vector, you can say linearly, okay, linearly independent vectors, independent vectors, okay, and spanning set, okay, they should belong to the spanning set, and they should be okay. So intersection of this is going to be the basis, and basis is nothing but a set of vector. Set, it is a set, okay, and the number of vectors in the basis is going to be called as dimension. Okay, so these are very important concept that you have to remember. Okay, so answer for this question will be what? Aditya, I think Sahil, both of you might have understood this. It's a very simple thing, right? Uh, Despite you don't know anything like dimension of column space, dimension of row space, but still we can answer this question. But please go through the way I'm telling you now, because these are important things that one must know. Okay, let's move ahead. So I think these are the questions that were given in the sample paper. So this is how one has to understand, right? So this is nothing but a linear algebra in nutshell, right? So what I was thinking that I will discuss from these things, right? So you can think about a very special kind of matrix that is nothing but a square matrix, you know. So linear algebra in nutshell. So these are the things I teach in linear algebra, and you should know also. So what are they? Suppose any matrix is there, right? So this matrix is nothing but what? I'm considering this matrix is a square matrix, you can say, kind of square. And if the matrix is square matrix, we can talk about two things, okay? Based on the determinant of the matrix, okay? The determinant of the matrix can be zero, and determinant of the matrix can be non-zero. So if the matrix determinant is non-zero, you can say that of this is non-zero. So you can say the matrix will be known as non-singular matrix, okay. And if the determinant of the matrix is zero, so we call it singular matrix. Now if you know that the square matrix is non-singular matrix, so what are the things that you can do with the matrix? Then what are the concept that you can find, or so you can say that the matrix A is invertible. Then these are the conclusion that you can make immediately, right? So first is A is invertible, right? And columns are independent then, right? If the matrix determinant is non-zero, means the rank will be full rank, right? Suppose rank of a suppose any matrix is given, right? Suppose let me take, suppose any matrix is given, right? You can say that A, B, C, D, C, E, F, right? G, H, I kind of. Okay. So this matrix has got 3 by 3, okay? And suppose this matrix is nothing but a matrix and its determinant is non-zero. What you can say? Rank of this matrix will be what? Full rank. Okay. So rank is full means number of linearly independent column vectors is gonna be 3. Here the columns are independent, then you can say linearly independent. Okay. So I believe everybody knows what is the meaning of linear independence. Because independence, linear independence, and dependence are very very important concept. Okay? And linear combination is also one of the very important concept, right? I also told you, okay, linear combination, linearly, okay, independent vectors, okay, vectors, understood. Please remember this. So A is invertible, the columns are independent, the rows are independent, determinant is not zero. Okay, can you say like this? Yes. And Ax equal to 0 has one solution, yeah, that x equal to 0. Ax equal to b has one solution, that is, you can say, kind of unique solution we are talking about. Okay, and Ax equal to 0 is also known as what? Ax equal to 0 is also known as null space, guys. Kya? Null space. What we are doing here is we are taking the matrix and we are multiplying with a vector, column vector you can say, and we are getting null matrix, null vector you can say. So this is null vector. So this is nothing but null space. Okay. Or whatever solution we are going to get, solution is going to be, okay. So this kind of situation, Ax equal to 0 is called homogeneous system of linear equation, right? Ax equal to 0 is the homogeneous, right? Null space, or you can say this is nothing but homogeneous solution, right? Homogeneous solution. Homogeneous solution. And Ax equal to b means this is non-homogeneous system of linear equation. Ax equal to b has unique solution only. If any matrix has full rank, right? So certainly it will be having what? Unique solution, right? X equal to A inverse b. Okay. And this system is nothing but what? This matrix is kind of balanced matrix, right? So the number of, in this case, what you can comment on, number of equations, number of unknown. Here the number of equations are equal to number of unknowns, and it is only possible in case of square matrix. If there is a number of equations and number of unknowns are same, means you will get always the square matrix. Okay, because from where we get the matrix, we get the matrix from, the system of linear equation, right? Okay, fine. So A has non-zero n number of non-zero pivots. Okay, if the rank is n, you can say the rank is n, it means number of pivots, number of pivots must be what? N. So if number of pivots are n, so from the definition we know that the rank is equal to number of pivots. Here मैंने बताया यहाँ पर देखो, rank of the matrix is nothing but number of pivots, okay? And that to non-zero values, right? So these are the non-zero pivots I'm talking about, right? So A has non-zero pivots, right? And A has full rank. You can say R equal to n. The reduced row echelon form is R equal to this identity matrix. The column space is all the n dimensional, okay, vector space. Okay. Row space is all, okay, because after all the balance system is this and the non-singular matrix is this. Okay, so everything is gonna be okay, and all eigenvalues are non-zero, guys. Ye dekho, connection with the determinant and the eigenvalue. Okay, or you can say connection with non-singular matrix and the eigenvalue, guys. Can you comment on that? See, if the one of the eigenvalue is 0, suppose there are three eigenvalues and one of the eigenvalue is 0, certainly the determinant of the matrix will be 0 from the product property that we know, right? So if the matrix is non-singular matrix, so you can say that all eigenvalues are non-zero. मतलब they can be positive, negative, whatever, but they must not be 0. अगर एक eigenvalue 0 हो गया, so the determinant is going to be 0 and that matrix will not be called as non-singular matrix. Okay? And this might be the new concept for you all, right? A transpose A is a symmetric positive definite, right? Okay. A has n positive singular values, right? And these are important points that you should understand, right? Now let us jump to singular matrix, right? Singular matrix. Okay, so singular matrix, like if the matrix is singular, right, it means the determinant is going to be 0, and if the determinant is going to be 0, you cannot find the inverse of a matrix. Yes, and the columns will be dependent. These are the remarks that you have to quickly make, and the rows are dependent. The determinant is going to be 0 ax. ये देखो यहाँ पर, देखो, system is balanced. Okay, system is going to be balanced here. System is balanced. Okay, a m cross n. So situation can be m greater than n. Oh, let me erase this. M equal to n, m greater than n, and m less than n. ये balanced है. Balanced system. Here, number of equations are more than number of unknowns. Number of equations are more than number of unknowns. You know, we always try to talk about like number of equations must be equal to number of unknowns. But see, there are two unknowns, two equations. We need to solve the equation, right? So that we can get the answer. But here, number of equations are more. Okay, number of equations are more, and number of unknowns are less. So what you can do here is, this is nothing but over-determined, kind of over-determined system. And what kind of this system is, guys? Underdetermined. Okay, underdetermined system. I think this is clear for all, yeah? Overdetermined, underdetermined. So in case of balanced, okay, remember that. ये बहुत important है. If the system is balanced, how you will come to know that system is balanced, system is unbalanced? Guys, tell me fast. कैसे पता चलेगा? Here the system is not balanced. Okay, balance means number of equation will be equal to number of unknowns, and according to the nature, you know, we always try to make the equation like number of equations. Suppose there are 5 variables, so we have to get 5 equations so that we can solve it, right? Okay, so number of equations, this is a balanced system. Okay, and this is unbalanced system, and this is nothing but, you know, so remember that first of all you have to check consistency, right? Okay, it should be consistent, and if it is not consistent, you can say not consistent. What is the meaning of consistent? What is the meaning of non-consistent? Consistent means the rank of the matrix. Okay, rank of the matrix, okay, should be equal to, I mean, as long as you can say that it is of the form ax equal to b, right? So the rank of the matrix A given B, you can say augmented matrix should be equal to rank of the matrix A. Right? This is meaning of consistent. Okay, understand? And in this case, if rank of the augmented matrix is not equal to rank of A, right, then it is not consistent. Okay, it is not consistent. So don't talk about it. If it is not consistent means no solution. Okay. But if it is consistent, so there can be two situations. Okay, this can be less than number of variable or greater than number of variable, right? So you can say that if it is greater than number of variable, okay, so there can be two situations. This is very important to keep in mind, right? Sorry, not, it can never be greater, guys. It will be always less only, right? So you can say that if it is equal to n, or you can say that less than n, it cannot be greater than n. That is very important. Okay, so if it is equal to 1, so you will get a unique solution. But if it is less than n, so you can say there will be infinitely many solutions. Infinitely many solutions. I hope everybody understood this. Yeah. Aditya, you understood this now? Fine. So this is very, very important to keep in mind. And in this situation, you can comment on here also, m greater than n. This is nothing but overdetermined system. Overdetermined system. And in this case, the number of equations are greater than number of unknowns, so you cannot get unique solution, right? In this case, you can never get the unique solution because number of equations are greater than number of unknowns, right? So unique solution is not possible. In fact, you will get infinitely many solutions, okay, or no solutions, you can say, right? Infinitely many solutions or no solutions. Uh, and in this case, you might get, so that is very important. I will come back to this, right? Then we will come back again. So आप देखोगे यहाँ की ax has infinitely many solutions, okay? Ax equal to 0 has infinitely many solutions. Ax equal to b has no solutions or infinitely many solutions, right? Two things are possible if the matrix is singular matrix. No solutions. No solution means not consistent, right? Not consistent, then you will get no solution. But if the determinant of the matrix is 0, means non-trivial solutions, okay? Non-trivial solutions or infinitely many solutions. Rank is going to be less than number of pivots, okay? Or number of variable also, you can say. Rank is going to be less than this. And R has at least one zero row. मतलब कोई भी whatever after elimination, right? Suppose you have got ax equal to b, right? What do you do in order to solve this equation? You have to go for Gauss elimination method. Gauss elimination method. Right? Gauss elimination method we apply and then we go for substitution, right? Back substitution. Substitution, right? Okay. So infinitely many solutions. Okay. So in this case, if you take a look here, so this row reduced echelon form, right? So one of the equation, right? One of the row is gonna be 0, right? In this case, one of the row. Suppose this is not 0, but one of the row can be 0, right? That is very important to keep in mind. Understood. So that is why I'm saying there will be infinitely many solutions. I will tell you more. And dimension of the column space. The column space has a dimension r, which is less than n number of variable. Row space has the dimension, which will be less than n. That is nothing but r only. Dimension of column space is what? Aditya, I told you, no. Dimension of column space is what? What is the meaning of dimension of column space? बताइए. More questions are there. We will take. Yes, one question is still there, right? The dimension of column space is nothing but rank. Dimension of row space is nothing but rank. Okay? So whenever they are asking in the exam, suppose they are asking question, what is the row, what is the dimension of row space? So what will be your answer, Aditya? बताओगे? What will be your answer? The answer will be rank of the matrix. Directly you have to find the rank of the matrix, and that rank of the matrix is going to be the dimension of row space or a column space, right? And 0 is an eigenvalue of A. Certainly one of the eigenvalue must be 0. Then only product of the eigenvalue will be 0. So that the determinant of the matrix can be 0, right? And A has R less than n singular values, right? Okay, I hope this makes sense. This concept is very useful. Okay. So your entire linear algebra is revised or not? I mean, some of the important concept. Yes, Aditya. Let's move ahead. So let us see this question, and I think you can solve this question, right? So what they are saying, this question is, again they have asked question from very favorite topic, that is nothing but eigenvalue. So consider a matrix X whose eigenvalues are 1, -1 and 3. The trace of this is what? What is the meaning of trace? ट्रेस का मतलब क्या होता है? ट्रेस ऑफ एक्स क्यूब माइनस 3x square. Trace of this is nothing but the sum of eigenvalue of x cube minus 3x square matrix. Yeah. So can you find Aditya answer? So for corresponding eigenvalues, x has these kind of eigenvalue, right? So what you can do here is in place of this matrix, you can put lambda, okay, by Cayley-Hamilton, right? So we have got here the matrix, you can say kind of new matrix Z, you can say that is nothing but x cube minus 2x square. So by Cayley-Hamilton, we can say that by Cayley-Hamilton theorem, right? We can replace any matrix or you can replace x by lambda. So the new matrix will become, okay, will be equal to lambda, you know, cube minus 2 lambda square, right? Now, what we can do here is, this is nothing but eigenvalue of g, right? So what we can do here is now for each given lambda, 1 is given minus 3, okay, 1 is given. So we can find the eigenvalue of g, right? This is nothing but 1 minus 2, which is minus 1. Minus 1 is given, so you can say this is minus 1 and this is minus 2, which is minus 3. Now we have given 3 here, so you can say that 3 cube minus 2 into 9. What is this? What is 27 minus 18? Oh, 3x square. Yeah, this is 3x square. Fine, fine. Very good. कोई दिक्कत नहीं है. Yeah, it is okay. Let me correct that. 3x square. Fine. Let me again calculate quickly. No problem. So, so here one is given. One is given, so you can say that 1 cube minus 3, which is nothing but minus 2. Here it is nothing but minus 1 minus 3. And this is nothing but 3 cube minus 3 into 9. तो 3 कॉमन ले सकते हो तो 9 minus 29. So 0 is there, right? So what is the trace of this now? Trace of g is going to be sum. So minus 2 minus 4 plus g. Minus 6 is the correct answer. Hope you understood, right? And if they are asking that what is the determinant of in this question? Det of x cube minus 3x square. What is det? Det of x cube minus 3x square. इसका det कितना आएगा आदित्य? डिटर्मिनेंट बताइए. 0. Very good. Okay, so these are the things that you have to remember. जो मैंने अभी बहुत ही important concept बताया कि that concept is very very important, so that you have to remember, right? Fine. So we will take some more questions and we can discuss the concept. Okay, so suppose we have got one question was there in GATE exam, right? You can say GATE 2019, right? So it was a question like consider a non-singular matrix. So any matrix you can say A is given 2 by 2 matrix, right, which is non-singular. Okay. So if it is non-singular means the det should not be equal to 0, right? So what they have given is trace of this matrix they have given. Trace of the matrix they have given 4, and trace of the matrix A square they have given 5. So what they are asking is they are asking the determinant of the matrix A they are asking. What they are asking? Determinant of the
It.
matrix A they are asking. So can you find this? See, they have given trace of the matrix, right? Trace of the matrix, okay? So trace of the matrix is nothing but what? How can you relate trace of the matrix from the determinant of the matrix? You have to recall what the eigenvalue of the matrix, right?
Eigenvalue.
So so eigenvalue of the matrix, sum of eigenvalue, you can say lambda 1 plus lambda 2 equal to 4, right? And lambda is square 1 is square plus lambda 2 is square equal to 5. Fine. I think this is
Yes.
clear. Now you can see that lambda 1 plus lambda 2 whole square equal to what? Lambda 1
5
square
plus
plus
2 lambda 1 lambda
lambda 2 square plus 2 times of lambda 1 lambda 2, right? So here you can write this as, I believe this is nothing but 16, 5
2 minus
plus 2
5
times
9
of lambda 1
11
lambda 2. Lambda 1 lambda 2 equal to what?
11 by 2
This is nothing but 11. So lambda 1 lambda 2 by 11 by 2, right? So product of eigenvalue is what?
determinant.
Determinant of the
Symmetric.
matrix. So you have to write, you have to divide this 11 by 2 up to some decimal. So I think now you understood this, right? How fast we can solve the question. Yeah.
Yes.
So your mind should be like this. I mean, there should not be any problem. Okay. One more question let us take here. Suppose we have got a question from 2019, 2018, GATE 2018. There are many questions, around 400 questions. So the value of x you have to find, the value of x. Right? So you can say that 4 minus x root 3, okay, root 3, 6 minus x, root is 0. Right? So what you can do here is this kind of question. Now they are asking x value, right? And options are given. If options are given, life is very simple. Okay. If options are given, life is very simple. How?
Just substitute.
Yes. But बहुत सारे people are there, they always try to do some labor, right? So life is very tough then, right? So you can substitute and check what does
B.
this indicate. It is indicating that this guy should be singular, that one page resume is enough to solve this kind of questions, right? Which I showed that time. Yeah.
Yes.
Fine. So next is suppose we have got a question from 2018 only. Suppose a matrix is given, you can say A matrix, which is nothing but A, B, 2 minus B, right? And X vector is given minus 1, 1, right? So if AX is equal to minus 3, 1, right? Then they are asking what is the determinant of the matrix. Right? Determinant of the matrix they are asking. What is the meaning of this? Are you understanding this? So first of all, what is the meaning of AX?
Linear
AX,
equations.
it means you are multiplying matrix into vector, right? Because x is a column vector multiplication, right? So you take here a b 2 minus b, okay, and you will get here minus 1 1, and the b is given as minus 3 1, right? So it is nothing but ax equal to b. So returning back, okay. So minus a this equal to minus 3, right? And minus 2 minus b, okay, okay, is equal to
1.
1. So I believe now you can solve for b here. So b is going to be minus 1, right? And you can plug here. So what is a? A is going to be 2. So a is minus 2, right? So now you can plug all the value. So A will be equal to minus 2, minus 1, 2 and 1. The date of this is going to be minus 2 and plus 2. Okay.
Okay.
But I think answer is not correct. I think we have done somewhere we have done mistake. Because we need to check out what mistake we are doing, right? So because if you're
A
solving
is
this
1,
kind of
sir.
equation, A is
A is
1,
minus
right?
1.
Yeah. Yes,
A
yes,
is
yes.
minus
You
1
can.
and
Yeah, yeah. So answer will not be 0, right? So there is a mistake. I mean, we have to be little careful, right? Just like I skip many steps, but here we can do properly, right? So A and B match A B 2 minus B and minus A. So now we can write minus A plus B equal to minus 3. Yeah. Next is minus 2
minus 2
minus B
minus
equal
B
to
equals
1.
to
तो B कितना है? B is minus 1. Yeah.
minus 1. Minus 3, sir.
Huh?
B minus 1.
Minus
Minus
3.
3, sir.
Yeah, minus 3. Yeah, because this guy will go this side minus 3. Yeah, perfect. And now this
A
is
is 0.
A. So A is 0. Perfect. Now you can put here. So A matrix will become
6 is the
0 minus 3 2 and plus 3. ये कितना आ रहा है माइनस 6 आ रहेगा राइट डेट इज 6 या डेट इज 6 ओके so this is very good question and I mean there is nothing like anything but it's fine. Suppose we have got a matrix. One more question. It was asked in 2016 ISC Bangalore only. So actually, ISC Bangalore has some sort of kind of they always ask some popular matrices, right? So if suppose x is given cos theta, sin theta, and minus sin theta, and this is cos theta. So can you identify what kind of matrix is this? You can identify this kind of matrix.
that
I
is 1.
believe. Huh?
That is 1. And x inverse is also the x.
So this is kind of
So
a
I think
matrix which
it
is nothing but rotational matrix or orthogonal also you can say, right? So let us see. So x transpose you have to find x transpose, right? So it's a very simple situation. X transpose cos theta sin theta, right? And minus sin theta cos theta. Now you can take the product here to cos theta minus sin theta and then sin theta.
identity matrix.
Huh?
Identity
Identity
matrix.
matrix. So identity matrix you are getting, right. So 1 0 0 1. So what is this? X transpose equal to identity matrix. It means
X
X
transpose is
transpose
equals
equal
to x
to
inverse.
X inverse. What is the what kind of property is this? This is nothing but
Orthogonal.
orthogonal. If the matrix is orthogonal and yeah, if the matrix is rotational, right? Matrix, so since it will be always orthogonal only, right? So like that you can click in the question, right? You don't have to solve this much. Okay? Very simple situations. Uh, One more thing. Suppose we have got a matrix A, right? Let me that this question is also was asked in 2016 only by SC, right? So a matrix A is given. Suppose 1 2 3 0 4 5 and 0 0 1, right? So what we can do here is you have to find determinant of A inverse. What is determinant of A inverse? What is determinant of A? What is the inverse A inverse of this matrix? A inverse of this matrix. So determinant of A inverse. I think you can directly
Joint
find.
C mod A.
No, don't needless to find a joint here, right? You can do in 1 second also because the eigenvalue of this matrix will be 141, right?
One,
Huh? Yes.
yes. 1 by
So
6.
and so
1 by 4.
A inverse eigenvalue will be what?
1, 1 by 4, 1.
1 1/4 1. तो इसको क्या करोगे डिटर्मिनेंट निकालने के लिए?
Multiply. 1 by 4.
So hope you understood, right?
Yes.
So this is how you have to do. Like, so many people where they will make mistake. Tell me first. They will go for adjoint of the
Adjoint A
matrix.
by mod.
Then they will find the determinant of the matrix, and then they will waste time. So 5 minutes to chala jayega. Okay. So I believe
Okay.
you have to understand this, right? So एक question और करते हैं. So the question is, like question 2010. I'm directly taking question, right? So I don't have solution also. I'm just showing you the moment you see the question, what kind of thought process you should develop, right? So that you should be able to save your time for other questions. ठीक है? क्योंकि इस question में आप आराम से you can save 2 minutes, right?
Yes, sir.
Suppose we have got a matrix M, 3 by 5, 4 by 5, X, and 3 by 5. So for a matrix M, 3 by 5, X, 4 by 5, 3 by 5. So the transpose of a matrix, here they have given that transpose of a matrix is equal to transpose inverse of the matrix. What is this? What is this?
Orthogonal minus 4 by 5x.
So you have to find the value of X. Life is very simple now. Value of X.
Minus 4
So
by 5.
they very good. How fast you have done, right? So this is minus 4 by 5, P is nothing but minus 3 by 5, C is nothing but 3 by 5, D is nothing but 4 by 5. So, whenever they are orthogonal to each other, so they are these vectors, you can say these are the vectors, right? I mean, so they are row wise also they are orthogonal to each other, right? You can say. So you can just take the product of this and equate to 0. You can say that x 3x by 5 plus uh, 12 by 25, okay, equal to 0. 3x by 5 equal to what is x?
That
But
determinant
other
is
people,
1.
yes, that is 1. Yeah, that is 1. Yeah. Acha, you have done that now?
Yes, that is 1.
Hmm. Yes, very good. Because if you see this M transpose equal to identity matrix, right? So that of this is identity, so that of this will also, yeah. So that you have find out, right? Very good. But the thing is, other people what they will do you know?
No idea, sir.
Uh, other other people they are going to find the transpose of a matrix. They are going to find inverse of a matrix, and then what they will do? They will answer the
Equate
question.
and
Okay, so our life will be very difficult then, right? So we have to take care of these things, right? So that you can save time. Now the question is, suppose one matrix is given, you have to find the value, right? The value of k, right, for which the matrix, you know, k2 3 1, k2 3 1, right? Does not have an inverse. What is the meaning of this? Does not have an inverse. These are conceptual questions, right? So can you tell me
That
answer?
is 0.
Does not, yeah, that is zero. Khatam answer, right? K equal to minus plus 6.
Or both rows are same.
Yeah, both rows are same. Yes, that also you can say. So both rows are same means yeah, both rows are same. So k equal to 3 and 2 equal to 1. ऐसा करोगे? Or you have to just apply elimination then, right? To make it same. So remember any like if you have got some special kind of a matrix like this, some kind of a you can say UTM kind of a matrix, upper triangular matrix, lower triangular matrix, identity matrix, okay, or kind of diagonal matrix, right? So eigenvalue will be what? Eigenvalue will be
They
the
are diagonal.
diagonal entries of the matrix, right? Okay. ये आपको याद रखना है. This is very important so that you can solve any question because I've seen many question has been asked from this, so you should be able to do. Suppose we have got a matrix like this, 2, 1, 5, minus 2, and they are asking that the positive eigenvalue of the matrix, positive eigenvalue of a matrix. Yes. So what do we do here? ठीक है?
2. Convert it into a lower triangle or upper triangle.
No, no need to do anything. Okay. The product of eigenvalues should be 9 and the sum of eigenvalues should be 3. So lambda 1 equal to 3 you can say. Lambda 2 equal to.
Yes.
So you have to always use what? That I've told you also. Sum
Some
and
product.
the product property. बस खत्म. Okay. You see how fast we can do it. Otherwise, if you think that what you said, what last time what you said, you have to convert what?
Convert convert into lower triangle matrix or upper
No,
triangle matrix.
no. No, 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 no. Never do, never do. Remember, this is very important. Okay, never ever, you know, apply Gauss elimination, right? While finding the okay eigenvalue. See, this is the different story. Okay, see if you are going to apply the eigenvalue, I mean, see Gauss elimination method we apply, okay, we apply some row elementary operations and all, right? So solution of the matrix does not change, solution of the equation does not change, okay. But if you're going to apply while finding the eigenvalue and you have applied some elementary operations over there, okay, then entire eigenvalue is gonna change, okay. ये पैराडॉक्स
Okay.
इसको याद रखना हमेशा. Many people do not know. That's why new concept comes into picture, right? So we were solving system of linear equation and we were very happy applying Gauss elimination method, right? And but while computing this eigenvalue, it is a new concept, right? We are decomposing entire big matrix into a single value. After all, this eigenvalue is a single value, right? It is not a matrix, okay? The entire big matrix is going to be discussed with the help of single value here, and this single value has more, you can say that it has very good meaning associated with any vector u. Okay. So remember, this is very important. Never do this. बहुत सारे लोगों को ये लगता है, but never do this. Okay. I hope this makes sense. क्योंकि by mistake we can do also in the exam, and okay, so life becomes very difficult. So we have to be very careful. Yeah. So let us, you know, okay. So is there any doubt you can ask now? Otherwise, we'll bind up the session. So sometimes what happens, see, suppose we are multiplying with the matrix, okay, so this might happen that suppose you have got some vector here, right, some vector x, and if you have got some matrix A, right, if you're going to multiply this matrix with this vector, so this vector can get rotated like this. Yeah, understood. So this is nothing but ax. Okay, so this,
Hmm.
if remember, so this matrix will be known as rotation matrix then, because it is rotating with certain angle theta, you can say. ठीक है.
Okay.
So what are the things that can happen with the if you multiply any matrix with a vector? So two things can happen always. One is the rotation of the matrix, I mean rotation of the vector, right? So the vector can get rotated, right? Rotation can occur, and what can happen? It can be stretched, right? Stretching, you can say. Stretching means the norms of a vector gets increased. Okay, norms of a vector gets in. You know what is the meaning of norm? Norm means length of a vector. ठीक है. So you will find many PYQs. Okay, so this is nothing but a rotation matrix. Okay, and rotation matrix will always be having like theta sign, kind of cos theta, sine theta, minus sine theta, cos theta kind of thing. Okay, and you have to multiply, and there will be some rotation. Right, fine. So what is the meaning of projection matrix? Projection. That's what I suggested, that Gilbert is trying at least some cover page you can go through, so everything will be clear, right? So a projection matrix is nothing but a square matrix. First of all, you have to remember that. Okay, this is nothing but n cross n matrix, okay, a kind of a square matrix that gives a vector space projection, right? That gives a vector space projection from the Rn, from this vector space to, you can say, subspace of W, right? So the column of projection matrix, okay, remember this is very very important key point. The column of any projection matrix, you can say column of P, okay, are the projection of the standard basis, okay, of the standard basis. So to understand everything, you need to have all the concept, like what is the meaning of basis vector and all, and what is base, space, all those things, right? So this is very important. So if any square matrix P is a projection matrix, so that will be giving you this kind of situation. Remember how to check whether the matrix is a, you can say that a projection matrix. So remember that if you can say a square matrix, because this is the hard definition that I have told you, right? But now easy definitions are, okay. So square matrix P is a projection matrix, you can say, if and only if, I believe this, right? P square equal to P. Right? This is how we prove. Okay, it is okay or not? ठीक है? Yes. So P square is equal to P is called the if P square is equal to P means it will be the okay, and the projection matrix P is orthogonal matrix. You can also do that. Yeah, the P is nothing but an orthogonal matrix also, right? So so if a matrix is projection matrix, a projection matrix P is orthogonal if and only if P is equal to the adjoint of the matrix P. What? Adjoint of the matrix P. Okay, and a projection matrix is symmetric matrix if and only if the vector space projection is going to be orthogonal. So there are many things that you have to understand. So let us take one example, okay, which is a projection matrix, but it is not symmetric. You can see, right? So you see, suppose this is a matrix we are taking 0 1 0 1. So 0 1 0 n is a projection matrix, right? So this is going to project into a line, you can say, like y equal to x, okay, if you're trying to write, okay. So p equal to 0 1, okay. So if you try to find p square, let us prove this, right? So 0 1 0 1 0 1 0 1. So 0, what we are getting here, 0 1 0 1. Yeah. So it is a projection matrix only, right? Okay. So this is very very important. So if any question will be given from the you can say projection matrix, so you can always prove. Yeah, it is a projection matrix. Okay, and there is nothing like that. Okay. Hmm. Any other questions? आपको बस prove करना है. And please revise. You know, Aditya. Concept of vector space, right? Subspace. Okay, and basis dimension, right? In fact, here you have to talk about linear combination, right? Linear combination, linear independent, right? Dependent, okay? Concept of spanning set, okay? So many things are there. Right? Please go through these things, and we'll meet in the next session on probability, right?